do composition of functions? I don't get it. Can you please explain?
Today we're going to be learning about composition of functions. Composition of functions means that for all x in the domain of G, such that g of x is in the domain of f. This is the basic formula. This means f composed with g, and this means that g of x is an input for f. Similarly, this means that g is composed with f, and this indicates that f of x is an input for g. Okay, let's try an example. We are given f of x is equal to 3x plus 2 and g of x is equal to 5x plus 1. So, from our formula, we know that f of g of x is written like this. Next, we know that f of x is 3x plus 2. But what we're going to do is we'll plug in the values of g of x, which is 5x plus 1, to x. So it becomes 3. Instead of x, we'll put 5x plus 1 plus 2. So we distribute that, so it becomes 15x plus 3 plus 2, which is equal to 15x plus 5. Okay, so let's try it the other way around. Instead of f of g of x, we'll try g of f of x. So according to the formula, it can also be written like this. So, like what we did a while ago, we'll plug in the values of f of x to the values of x in g. For example, g of x is 5x plus 1. So, we'll write it as 5, but instead of x, we'll replace it with the values of f of x. So, multiply it by 3x plus 2, and then plus 1. So distribute 15x plus 10 plus 1. 15x plus 11. This is your final answer. Example number 2. Given that f of x is equal to 2x plus 5 and g of x is equal to 4x plus 3, let us find f of g of x. So from our formula, we know that this is equal to this, f of g of x. Next, we'll plug in the values of g of x to all the x values and f of x. So from f of x, we know that is 2, and then you plug in these values, so 2 times 4x plus 3, and then copy 5. Next, distribute. So 2 times 4x is 8x, 2 times 3 is 6, plus 5, and then simplify. 8x plus 11. This is the final answer. Okay, so since we found f of g of x, let's find g of f of x. From the formula, we know that it can also be written like this. So now, we're going to plug in all the values of f of x in the x values of g. So, g is 4, but instead of x, we'll write 2x plus 5. And then, copy 3. So distribute 4 times 2x is equal to 8x. 4 times 5 is equal to 20. Then add 3. So simplify 8x plus 23. This is your final answer. Okay, now we'll be talking about decomposing a composite function. Okay, so let's say that the given is h of x is equal to quantity cube root of x plus 1 squared minus 3. So what we're going to do is we're going to assign g of x to all the values inside the grouping symbol. So in this case, the grouping symbol is a parenthesis. So g of x would be equal to cube root of x plus 1. Next, let f of x be equal to x squared minus 3. Since we already assigned g of x to cube root of x plus 1, we'll label it as x squared and then minus 3. So now, we know that f of g of x is equal to this. Now, let's replace all x values of f of x with g of x. So, we have cube root of x plus 1 minus 3. And since this is the exact same thing as our given, which is h of x is equal to cube root of x plus 1 squared minus 3, we know that this is equal to h of x. And that's your answer. Okay, let's try another example. Okay, number 6. Given that h of x is equal to square root of 3x squared plus 5. Again, let g of x be equal to the values inside the grouping symbol. In this case, all the values are grouped under a square root sign. So g of x will be equal to 3x squared plus 5. Now, since we already assigned this to g of x, let f of x be equal to square root of x. Okay, so f of g of x can be written like this according to our formula. Now, we're going to replace the x value of f of x with g of x. So, it can be written as square root of 3x squared minus 5. And since this is exactly the same as our given, we know that f of g of x will be equal to h of x. And that's your answer.
Oh, I get it now. Thank you.